All right, this is going on page 80 when we're done. And this topic, so we're starting unit 3, which is basically the trig unit. We're not going to talk about trig at all today, but it connects, I promise. It'll make sense how it connects once we get into the stuff. But this is called periodic phenomena. That is plural for the word phenomenon. And when I hear the word phenomena, I hear a little song in my head. So I'm going to make you have that song in your head too. And it's from the Muppets. Here we go. Oh, wait. It's going to start at the wrong spot. What are we doing? Way down here. There we go. Kermit is frozen. Come on, Kermit. Come on, Kermit. Why won't he play?
And if that weren't enough, we've also got phenomena, whatever that means.
Y'all heard this, right?
Phenomena.
Sounds like phenomena, right? Phenomena. There's your earworm for today. So phenomena, what you think of that song every time. All right, so, but it's periodic phenomena. So in the library, there's a place, well, there used to be, honestly, I don't know if there is anymore because so much stuff is digital, but there used to be at least a section called the periodicals. Do you know what periodicals are or what periodicals will be in the library? No, that's because everything's digital now. But a magazine, so the periodic section or the periodicals, you used to you couldn't actually check them out because they'd be newspapers and magazines, like you could read them, but you couldn't check them out. So the periodicals would be newspapers, magazines, things like that in the library because they come out periodically. A magazine might come out once a month. A newspaper might come out every day or once a week, but it happens in a certain time period, right? Whether it's weekly, daily, monthly, whatever's happening, that makes it periodic, all right? And you have 7 periods in the day, which are about the same amount of time. In theory, they would be the same. So a periodic relationship between 2 variables occurs when the output values demonstrate a repeating pattern over successive equal length intervals. So if you have a weekly newspaper, our successive equal length intervals would be 1 week. They happen once a week. That makes it periodical, okay? So the period of a periodic function, because we're talking about them as functions, is the length of the x values it takes for the function to complete 1 cycle, okay? So let's think about that. We've got this little graph here, right? And if I look at this graph and I can see that, I would say that we start maybe here and I've got this amount and then I need to calibrate my board. All right, I'd have that and then you see how that could repeat. We agree with that? Could I also take the whole thing that was printed and just repeat that? I could, right? But when we are looking for a period, we are usually looking for the smallest possible number to be that period. So here, if I start at -1 and go to 3, this distance right here is 4. So the period for this function is 4. We okay with that? Because I go 4 units and then I repeat the same thing and I repeat the same thing and I repeat the same thing. So it tells me here that the period is 4. So we have a portion of the graph. So I know it says to draw. We'll get there in a second. But I want you to think about what's happening here for us to draw. I know we can count and all that stuff. But if I look at f of -1, first of all, f of -1, what does that equal? 1. F of -1 is 1, okay? But it also equals f of -1 plus 4 because 4 is the period. And overall, this gives me 3. Right? -1 plus 4 is 3. And you can see that f of 3 is also 1. This is also equal to f of -1 plus 2 times 4. Because again, 4 is the period. This whole thing would be 7. And f of 7 is also 1. Does that make sense to you? So every output that gives me a +1 would be -1. The input would be -1 plus or minus some multiple of 4. Okay? Any multiple of 4 because 4 is the period. So this could also be f of -1 plus 3 times 4. 3 times 4 is 12, so this whole thing would be 11, which means I know that at 11, I also have a 1. If I did f of negative 1 plus 4 times 4, that'd be 15. So at 15, we also have that. Again, I know on the graph you could just count 4, but we need to understand it functionally as well. That means, again, overall, this would also be equal to f of negative 1 plus k times 4. K being some constant, some integer that is positive or negative. So k could be a negative 2. I could subtract 8, and then I would be there at negative 9. All right, but it gives me all of them, so I wouldn't have to redraw everything. When we look at f of 1 is 3. So if I add 4 to 1, I get 5, and I'm at 3. I add another 4 to 5, and I get 9. Add another 4, I'm at 13, right? If I have f of 2 is 3, so that means f of 6 is 3, and f of 10, and f of 14, and then there's my little connections there. It's very important that you understand how the period is working in this function. So ask me questions if I need to restate something or re-explain it or explain it a different way. Third period hardly ever talks to me and asks questions. We had a lot of good questions this morning. Any questions at all right now about where anything came from? Do you understand the concept about it's just happening every 4? That's why we can add or subtract some multiple of 4 and we would have the exact same output. We good so far? Maybe? Okay. Let's look at this next one. Now here it says a portion of the graph of the periodic function, so it's telling me it repeats. What is the least possible value for the period? Okay, so remember, we're always looking for the least possible value of the period. What do you think the period would be here? What would be the length of the x of the domain, my x values, before I would start repeating the pattern? And you can start anywhere. 5? Do y'all agree with that? Yeah. Okay, so you can start anywhere. When we get into the trig stuff, my suggestion always is, even though we can start anywhere, if you can start at 0, it usually makes your life a little bit easier. So I'm going to start here, and this would be 1 period, and then it would start to repeat, right? Kind of looks like a check mark. And I'm going from 0 to 5, and that means my period is 5, and I agree with that. Now, did I have to start there? No, and a lot of you might have started at the beginning. If I start here, then I would end here, and I'd be going from -2 to 3. That is still a distance of 5. It's totally fine. It doesn't matter, okay? There's nothing set in stone about what the pattern is that actually repeats. We all good so far? So that we all agree that the period is 5. Yes, but you do want to be careful. Like if I started here and went like to the left, you see how that doesn't actually go 2 like this does? So you want to make sure you actually get a full cycle no matter where you start, okay? Any questions at all at this point? All right, so now without drawing, because look, we want g of 72. I definitely don't want to draw all this stuff out. We're going to use the function and use the period to help us. Now, the period is 5. So I want to change this g of 14 into g of something plus or minus some multiple of 5. So the best way I think about this is that my period is 5. 5 goes into 14 evenly how many times? 2. Okay, so this is going to be plus 2 times 5, because that's 10, right? And what was left over? 4. Okay, so it's g of 4 plus 2 times 5. This 5 is the period, right? I'm not just making up numbers. You get to ignore this part of it and just find g of 4, because I can do that on the graph that I have. And what is g of 4? 7? 7. Okay. Sorry, I can't scroll more for those of you in the back. Everybody okay with that? Does that make sense? All right, so we're going to do the same thing for b. 5 goes into 72 evenly how many times? 14. So I'm going to do plus 14 times 5. Okay, 5 times 14 is what? 70. So I have 2 left over. I'll scroll and then scroll back. So really I'm looking for g of 2, because I get to ignore that, and it is 6. G of 2 is 6. Okay. Y'all understand how this works? Because it's a period. All right. Now remember, I can add or subtract multiples of 5. So I'm thinking since this is a negative 17, I'm going to have to subtract. So negative 5 goes into negative 17 how many times? Evenly. 3. So I'm going to do minus 3 times 5. So what minus 15 gives me negative 17? 2? Negative 2. Yeah. Negative 2 minus 15. So then I get to ignore that because that's a multiple of 5. I just want g of negative 2, and that is 7 again. Okay. Do you understand how to manipulate the numbers to make it work? Any questions at all? Okie dokie. Flip it over. Now, here's the same concept, but with a table. And so this says the graph of h is periodic, so I know it repeats, with a period of 5. Now, one of the questions I did have earlier today was, what if we have a table and they don't tell us the period? I can't imagine that that would happen, okay, because you would have to imply some stuff and assume some stuff. If you have a table, they're going to tell you the period, or you'd have a lot of information and it would be really obvious, but I wouldn't worry about it. I don't necessarily foresee that happening, okay? So the values of h are shown at selected values of x. So the nice thing about the graph we just did is there was really an infinite amount of numbers I could have used, right? But here I only have 4 numbers I can even choose from that I actually know the value of. And because I'm not exactly sure what's going on. Plus it's a period of 5, not a period of 4, so I can't even write out the rest of the table. So I need to change this into something. I need negative 2, but it's got to be something, some number from the table, from the x values in the table, plus or minus some multiple of 5 that would give me negative 2. So what number could I use from the table to add or subtract 5 to get negative 2? What do you think? 7, and then do what? Minus 5? What does that give me? That gives me positive 2, so that doesn't work. Okay, no, it's got to be plus or minus the period. It would be 3. Good. 3 minus 5, does that give me a negative 2? Yes? Okay, so since this right here equals a negative 2, which is what I actually want, I can ignore this because that is plus or minus my period and just look for h of 3. And what is h of 3? 0. Okay? Everybody okay with that so far? All right. H of 6. Oh, I don't know why I put equals. This should be, there should be no equal sign there. What the heck am I even doing? Y'all know there's no equal sign there. None of y'all fix me? Come on now. All right. Yeah, it was supposed to be equal in the front, not like h equals. That didn't make sense. Okay, sorry about that. So equals h of, that's what I intended to do. Some number from the table plus or minus a multiple of 5. What's the number from the table? 1 plus 5, right? This is the period or the multiple of the period. So I get to ignore it, which means I can find h of 1, and h of 1 is negative 2. Questions? Anything? Okay. So then I have h of 9. So I need h of something plus or something from the table plus or minus a multiple of 5. What would it be? 4. So it'd be 4 plus 5. I get to ignore this because it's the period part of it, right? So I really have h of 4. What is h of 4? 3. So then I need h of 3. 0. And that's on the table, so that's nice. And that's 0. Okay. Any questions? Okay. So I've got h of 5k minus 3. Now I'm going to rewrite this so that so it looks like what we've been doing, and make this h of negative 3 plus 5 times k. Okay, so now it looks like what we've been doing with the period next, right? So I can't just find negative 3. Right now I can't just ignore that part like I have been. Instead, I got to find some value of k, like what multiple of 5 plus, or what multiple of 5 minus 3 would give me something up there? Like how can I make this into a number from that table easily? What could K be? 2. If I made this into h of -3 plus 5 times 2, that would be 10, right? So then that would give me h of 7. Is that something I can actually calculate? Yes, h of 7 is 2. So we had to think about this. This one was a different thought process than A, B, and C, right? So you have to figure out how you need to manipulate it to make things work. Like it didn't ask me what K is, but I needed to figure out what K would make sense so that I can get a number from in there. Okay? Ask me questions. Anything from anybody? Nope, we good? All right. So it is useful to have notation to model this phenomena. A periodic function starts with a basic pattern, then translates the pattern repeatedly over its domain. As a result, we're able to consider a periodic function as a horizontal translation of itself. Right? That's a big key point going into trig stuff. So if I look back at this one, right? So let's imagine that this actually repeats from -infinity to +infinity, just keeps on going forever in both directions. I could pick this up, like if I could take the graph off the grid, and I could translate it to the right 4, put it back down, it'd look exactly the same, right? I could pick it up, translate it to the left 8, and put it back down, right? Left or right, any multiple of 4 would look exactly the same. That's why this function is a horizontal translation of itself. So I can rewrite it multiple ways. This goes on to say that because of that, if you have a period of 5, then if you can translate the graph horizontally 5 units left or right, then h of x is going to equal h of x minus 5. It could also equal h of x plus 5 or h of x plus 30, okay? Just because it's, either way, okay? Or doesn't really matter. They would look the same no matter what when you graphed it. Everybody good so far? All right, beautiful. Example 5 here. We have that says f is periodic with a domain of all real numbers. 2 full periods of f are shown. Find all input values of f that yield an output value of 1. All right, so here is one cycle. So then what is the period? 4, because I'm starting at 1, going to 5. So the period is equal to 4. We all good? I want there to be an output value of 1. Here's my output value of 1. So then I know that f of 2 equals 1. And because, yeah, and f of 6 also. Because how many inputs would there be that give me 1? An infinite amount, right? Because it keeps on going. There's an infinite amount of inputs that are going to give me an output of 1. Obviously, I'm not going to list an infinite amount of them, right? So instead, I want to think about this how we've been doing it. That means that f of 2 plus k times the period, which is 4. And no matter, so I could add or subtract some multiple of 4, and I would still get 1. Does that make sense to you? Right? Okay. So then, and I know that this is going to equal 1, no matter what k is, but k is an integer, could be positive, could be negative. So I could subtract 8, I could do, whatever. But now, so that's kind of my answer, but I say kind of, because it says find all the input values of f that yield an output value of 1. We have implied what it is because we showed that we do an input, but to actually answer the question, this isn't actually my answer. My answer would be x equals 2 plus k times 4. Do you see how that's different? And some of y'all on the test, I don't remember what the actual values were, but it asked what is the x value that gives you something, I don't know. And some of y'all put f of 3 equals 2, right? And the answer was 3. I don't know what the answer was because I'm making this up, but let's say the answer was 3. Well, you didn't really say that x equals 3. You did this and it implies it, but we have to make sure we're actually answering our questions. Does that make sense to you? We're good on that? Okay, that's just a little side note. Everybody good on this so far? Any questions at all?
Wait, is that 4 after the 4 just we did?
I don't know why that 4 is. Oh, no, I don't think that's a 4. I mean, I know it looks like a 4. It absolutely does. I think I was like my pen, I was just tapping there. So thank you. Yeah, no, there's not another weird 4 there. Okay, now before we move on to the next piece of paper, there are these pink laminated things on your table. Grab them. You're going to work with your shoulder partner. So I just put 2 on each table so that everybody could, I mean, you can work as a table, but you want to be able to see this. Okay, listen. FRQ3 will definitely have a little graph that looks exactly like this, same letters, same everything. And the part of the instructions will sound like this. The graph of H and its dashed midline. Okay, now we haven't gotten to the part where we've actually talked about midlines yet. So let me give you the really difficult definition. The midline's in the middle. Okay, so this dashed midline is literally in the middle between these other 2 lines because it's called a midline. We can handle that? Okay, there you go. I know. And 2 full cycles are shown. 5 points, F, G, J, K, and P are labeled on the graph. Then here's where things go off the rails. No scale is indicated and no axes are presented. All right, so here's what that means. That means this is a graph that would go on a coordinate grid that you are used to. So even though there's no X or Y, because this little curve, depending on what's going on, could exist here, it could exist here. It could exist here, it could exist over here. Does that make sense? So I'm just, because if I put them on there, I'm telling you exactly where it is, and that's not something you're going to be told. But, and I think because I also did this last year, there was much better understanding, but the year before that, holy heck. Because they're not presented, but they exist. So when you put ordered pairs on here, your X values still have to go least to greatest left to right. Your Y values still have to go least to greatest bottom to top. Does that concept make sense? Because I would have people take their ordered pairs and do like -3, 0, 3. And I'd be like, in what world does that make sense for your Y values? And I could not make them understand why that was wrong. Do we all understand why this is wrong? I can tell by the looks on some of your faces, like, why would you think? I don't know either, and I could not fix it for some people. I tried everything. So that's one reason why we're doing this right now, to help you wrap your mind around it. Okay, we good so far? All right, so I'm going to give you a set of ordered pairs, and I want y'all with your little groups to put these in there. Here's your first set of ordered pairs. Put them where they go on that graph. And then I'll tell you after y'all do this first one how I would approach these. Okay, now as far as ordered pairs go, these are kind of pretty numbers, wouldn't you agree? There's no crazy fractions, decimals, there's not a ton of negatives and everything everywhere. So these weren't necessarily that difficult, okay? Hopefully we got them on there in the right place. But because things will get much different than this, let me tell you how I would approach it, because it kind of helps make everything make more sense when it does get a little bit more complicated. Because you'll know at least some of your ordered pairs, if not all of them. You are going to have to come up with them, but you'll have them listed out. I start by looking at the Y values, okay? And I say, okay, of those Y values, my biggest Y value is 40, so they got to go here. My smallest Y value goes here, okay? Now, if I didn't even have the other 2 ordered pairs, because this is a midline, I know that this Y value has to be halfway between 0 and 40, so I know it's 20 without even looking at my ordered pairs, okay? I'm not saying you shouldn't look at them, but I'm saying if you don't know them, this is also how we figure them out. Then we look at, then I'm going to go back and look at the ordered pairs that have the 40s in them, this one and this one. And the smaller of the 2 is a 4. But I have to also be careful to see if that is really my smallest X value that I have, because if not, I might have to do something additional, which I'll talk to you about in just a minute. But is 4 the smallest X value overall? Yes. Okay. So this is 4, and this one is 12. And then again, without having to look at anything, any of the ordered pairs again, not telling you to ignore them if you have them, but not only is the y-axis divided evenly, so are our x values every time on a graph like this. So if this is at 4 and this is at 12, halfway between those two right here is 8. And then halfway between 4 and 8 is 6. Halfway between 8 and 12 is 10. But I also have the ordered pairs, so I could have handled it just fine. Okay, we okay on that? Questions? All right, we're going to do 2 more. Here's the next one. Okay, so I'm going to start with my y values, right? My largest y value is 6. My smallest y value is a -4. And then the other ones are the ones. Okay, did we get those at least? We're good on that? Yes. All right, so then I'm going to look at my largest ones. Here is 6 and 6. And so I have a 0 and a 0.20. Is the 0 the smallest x value overall? Yes. So if that's true, then the rest is just gravy here, because this is 0, this is 0.2, which means this is 0.1, this is 0.05, and this is 0.15. Okay. So when I've said if it's the smallest, then the rest is gravy. Here's what you might have to do. Listen, our inputs on these, every single one I have ever seen for this, t is time. Okay. Can you have negative time? No. Okay. So in order for you not to have negative time, you might have to, on some of them, you didn't have to on either one of those, but you might have to back up a little bit and put one or more of these 3 points on there so that you don't end up with a negative time. You with me on that? And so that's where you might have to reason through where some things actually go. You'll know exactly where the y values go. Those are no-brainers, right? And then, but you might have to scoot things over, which means you might have to write additional ones over there. Okay, so I'm going to give you one of those. See what we can do here. All right, so erase that, unless you had questions. Anybody have questions on it? Okay, then let me give you these ordered pairs. And these are in no particular order. Okay, there we go. Oh yeah, 3 is 0. Okay. So it has to be 0s here. And then 3 over here. Yeah, exactly. That means the one you go back. You go forward or back. Yeah, okay, so 5 and then 5 again. Yeah, okay, so you have again, these are pretty numbers at least, right? We don't have crazy numbers yet. Oh, you're so smart. All right. Do we agree with my y values? Okay. So then I go look at my ordered pairs with the 3. That would be this, and there's only one of them, right? So is 15 my smallest y value? I'm sorry, my smallest x value. No. So then if I can't put 15 here, and then I'm going to end up with some negative stuff going on, right? Because if I make this 0, 0, this one 0, 0, this would have to be negative. We don't want that. That can't be happening. If we make this point, 0, 0, this would have to have a negative t value. That's why we cannot make this 0, 0. You with me on that? So I have to back this graph up and put at least one of these 3 points there, maybe more. Okay? Can I put 5, negative 3 right here? Yes. No, because that would make this 0, 0, and that would make that negative, right? So can I put 0, 0 here? If I put 0, 0 here, would that be 5? So if I put 0, 0, 5, negative 3 still can't go here. Can 5, negative 3 go here? No, so I don't like 0, 0 there either. So over here, I can put 5, negative 3, right? And I can make this 0, 0. And then what would this one be? Something 0, right? 10, 0. Because look, I'm counting by 5s. 0, 5, 10. So what's this one? 15, 20, 25, 30, 35. So that you have positive time. Okay. We okay with that? Questions? Again, depending on the information that you have, it could be that you only listen. Did y'all not hear me at the beginning saying this was very confusing for some people? This may not be where you start. You may start here, you may start here. It just depends on the information that you have. Okay? We're going to do a lot of these. Trust me, you're going to get pretty good at this, but you got to understand that you got to pay attention to it. Right? So now let me ask you this. On this particular one, what is the period? What do you think the period is? The period is the x values before the pattern repeats. This just keeps repeating? I don't think so. Look, okay, stop yelling numbers at me for a minute. Okay, so I could start here and then end here, or I could start here and end here, or I could start here and end here. So the period would be 20. Okay? We okay with all that so far? Questions? All right, now grab your other sheet of paper. This is also going on page 80 when we're done. This is part of an FRQ3. You see all those words? They are all crazy wordy. That does not mean they're difficult, but you do have to actually read all the words. But watch as we go through. We don't even have to read it all the way through once first. The figure shows a large clock mounted on a vertical wall. The clock has an 8-inch long moving minute hand. All right, so right now, I'm going to stop reading, and I'm going to go and label this minute hand as 8 inches. All right? And then I'm going to keep going. The center of the clock is 120 inches directly above the floor. So here's the center of the clock. That's 120 inches directly above the floor. I'm going to label that. Everybody good so far? At time t equals 0 minutes, the minute hand is pointed directly up at the 12. I know y'all can't tell time, but hopefully you know what the minute hand is. And thankfully it didn't tell you 12 o'clock. It said directly up at the 12. So at t equals 0, it's right here. However, the clock is not working properly, and the minute hand is moving twice as fast as it should. Thus, the next time the minute hand points directly up at the 12 is at time t equals 30. So we're here at 0. 30 minutes later, we're back here. That makes sense to you? All right. As the minute hand moves, the distance between the end point of the minute hand and the floor periodically decreases and increases. Here's what that means. Right now, the tip of the minute hand furthest away from the floor. then it gets to the closest, and then it gets furthest again, then closest and furthest, and it's just the distance is changing. That's why it's going to look like this. Okay, we're good so far? Yes. Oh, you're just thinking, okay. The periodic function h models the distance in inches between the end point of the minute hand and from the floor as a function of time t in minutes. Okay, so my input is minutes, my output is distance from the floor. So right now with all of that, I should be able to get at least 2 ordered pairs, because I know at 0, the hand is right here. At time t equals 0, how far is that from the floor? 128. Okay. And at 30 minutes, where's the hand? 128, because it's right back at the beginning, right? Okay, right? There, 0 and 30. You with me? So that means then at 15 minutes, it's here, right? 30 to go all the way around, 15 is here. How far is it from the floor at 15 minutes? And careful with your answer. I heard 30, 112. Okay. I know, nobody listens to me. 112, because the 120 goes to the center of the clock. This is still 8 inches, so I had to subtract the 8 from the 120. Or somebody asked about diameter. Okay, we can think of it as diameter. If this is at 128, the diameter is 16, you subtract 16, you still get 112. Okay, we okay with that? Questions so far? You see how easy it was to get those 3 ordered pairs? All right, so let's come down here. What is my largest y value? 128. So I can put those in. What's my smallest? 112. Okay, now that means here I'm at 128, right? Here I'm at 112. But what about halfway in between? That's what? 120, because that's right there. That's the center of the clock, right? So they kind of already told me. I mean, you could average them, but this would be 120 here. Everybody good so far? Okay. Then that first ordered pair I had for 128 was 0, 128. 0 would be totally fine to put here, because that means if that's at 0, I won't have any negative t values, so I'm good. So that's 0, this is 30. And this is 15, and we already knew that, right? But remember, not only are our y values spaced as equal length intervals, so are our x values. So what's halfway between 0 and 15? 7.5. Believe it or not, sometimes I don't hear 7.5, I hear some other ridiculous number. So what you can do, 7.5, totally fine. But you could also leave it as 15/2, and that's completely acceptable as well. Might not be a bad idea, so we don't do something ridiculous even on something easy, right? And then halfway between these two, I would add 15 and 30, get 45. I can just leave that as 45/2. 22.5 is fine too, but if you divide wrong, you're wrong. Or if you just leave it, you're good. Okay? What questions do you have? Okay, do you see how everybody understands how we got the numbers from the question and got them onto our graph? Yes? And how everything is spaced nicely. That'll happen every single time. Okay, we are going to stop here for today because I don't want to be screaming over the announcements. We will finish this little part tomorrow, and then you'll also get your review and stuff tomorrow. I am going to go ahead and give you your assignment, though.